Hey, sixth graders. So we're still talking about area. So we know all the way back from fourth grade how to find the area of any rectangle, right? That's just base times height, kind of like we were talking about yesterday. Now we want to find the area of this guy. So this is a woodlot. And in the directions, they're giving us the length of the sides. So side AB means the line between point A and point B, and that's 10 units. FE, so between F and E, is 8. AF is 6. DE is 7. So now we have to find the lengths of the other two sides. Well, check out this. Side DC all the way down here. That would be the exact same as if I put an imaginary line right there. So I know that this line is 10, AB, and this is 8. So that tells us since this and this would be the same. So then DC is 2 units. And then we still have to figure out CB, or BC. We like to go in alphabetical order. Well, I know that AF is 6 and ED is 7. And they are clearly the same, if I put them together, are the same length as BC. So 6 and 7, 13. So DC is 2, BC is 13. Now hold on, it's going to throw us again, so let's try with some different numbers. So now DC is 10 units, FE is 30, AF is 28, and BC is 54. Alright, now find the lengths of the other two. Well, I know to get line AB, I would have to add FE and DC together. So that's 40. And then to get line ED, I would have to take the length of this one and subtract this. So 54 minus 28 is going to be 26. So that's some of the logic and the mental tricks you need to use in this kind of math. Alright guys, I already made some scribbles here, so let's talk about what I did. So for this irregular polygon, remember a polygon is a shape, and irregular means it's funny looking. We know how to find the area of a rectangle, that's easy, so I divided it into 3 rectangles. We were given the base and height lengths for this one, so we could easily find that this one was 8 meters squared. 4 times 2, 8 meters squared. And then these are clearly identical, so we could say that this is also 8 meters squared. For this one, we didn't do 9 times 7, because 9 is for this whole side. So we took out the 4 meters for this side, and we're left with 5. 5 times 7 is 35 meters squared. So now we have the area for 3 different rectangles. 8 for this one, 8 for this one, 35 for this one. If we add them all together, it is 51 meters squared. So here we have a diagram of a stage being built for a middle school. And we're going to find the area of the stage using 3 different methods. So first we're going to use 2 horizontal lines, then we're going to use 2 vertical lines, and then we're going to use 1 horizontal and 1 vertical. Now, since it's the same stage for all 3 diagrams, we should end up with the same number each time. Let's start out with our 2 horizontal lines. Boom, boom. So this is the same dimensions we had earlier. So here we have 8 meters squared, 4 times 2. The same for this guy, 8 meters squared. And then here, we know 9 is this whole side, so we have to take out the 4 meters we already accounted for. And now we're left with 5. So this is 35 meters squared, for a grand total of 51 meters squared. Let's try the next one where we're supposed to use 2 vertical lines. I guess we'll go like this and like this. So now we have 9 by 2, so 18 meters squared. And then this guy, well, let's see, it lost 2 meters on this side and 2 meters on this side, So now this base is 3 meters multiplied by the 5 meters that we're left over with here. So here I'm going to write in the new dimensions, 3, 5, for a grand total of 15 meters squared. If we add them all up, that gets us to 51 meters squared again. All right, now on this last one, one horizontal line and one vertical line. So let's go horizontal, vertical. So now we have 3 different rectangles. So we've got, let's see, I'm going to write in some new ones. So 4 meters there, go away. You're 5 meters. But I still have my 9 because I have 4 and 5 to equal the 9 that I had there. So we already know this guy. This is 8 meters squared. But this is a new one. So this has a side 9 times 2. Okay, so there's my 18. So 8 and 18, so that's 20 meters squared so far. Or, no, it's not. Bad job, Miss Vandenhook. 8 plus 18 is 26. And then I'm left with 5 and not 7 meters, because I'm taking 2 meters out here. So this is 5 meters for 25 meters squared. And add it up, and we're back to 51 meters squared. So 3 different ways, but we all come out with the same answer. So let's think of this guy as a rectangle with a piece removed. So what are the dimensions of the large rectangle and the small rectangle? When it asks for dimensions, it means the base and the height. So the large, it looks like we have 9 and 7. So we're going to write it like this. We're going to say 9 by 7. And then the small one, we know this is 4. We have to figure out how much this is. Well, we know the bottom one is 7. And then we're taking out 2 and another 2. So 4 by 3. So what are the areas of the 2 rectangles? Well, 9 times 7, 63. And 4 times 3 is 12. And then we want to add in meters squared, meters squared. So what operation is needed to find the area of the original figure? Well, area we usually find through multiplication. So what's the difference in area? Difference, you heard subtraction. So the difference in area is 63 minus 12. Well, the difference in area is 51 meters squared. Are we sick of that number yet? So what do we notice about our answers to A, B, C, and D? They're the same! Now let's look at this parallelogram. So this is parallelogram ABCD because we name shapes by the name of the points of their vertices. So we know the base is 6 and the height of this parallelogram is 4. So draw a diagonal from A to C. Boom. Now we've divided it into 2 triangles. So find the area for both triangles ABC and ACD. And I'll tell you that the area for these 2 is going to be identical. Because we know the base is the base is 6 and the height is 4. So let's use our formula for triangles. So 1/2 base times height, or in this case 1/2 6 times 4. So the parentheses first, 6 times 4 is 24. So now we have 1/2 of 24. So please remember that multiplying by 1/2 like we're doing here is the exact same thing as dividing by 2. And 1/2 of 24 is 12. So the area of both triangles is 4 meters squared. And if we drew in the other diagonal from B to D and found the area, it would be the same. So we're still at 12 meters squared. If we add our triangles back together, we would find that the area for the whole parallelogram is 24 meters squared, which would just have been the base times the height. So the area for a parallelogram is the exact same as a rectangle. So let's try something a little cooler. Let's work on some trapezoids. So we're going to pretend that the trapezoid is a drawing of a garden plot. So we have the top base, the bottom base, and the altitude. So we need to divide it into some triangles, ABC and ACD. So we're dividing it into our two triangles. And now we need to find the area of each triangle. So we have a base and a height for each of them. So let's see, we have ABC. The base is 8 and the height is 5. So it's going to be 1/2, because that's the formula for triangles. 8 times 5, which equals 20. And then ACD is going to be 1/2 4 times 5. And that equals 10. So we found the area for both triangles, so then the area for the trapezoid would be to add them back together. So 30 meters squared. So I want you to talk to your partner about how else could we find the area. Come up with a strategy of your own and then move on to the problem set. Good luck.